Okay, so the last section of chapter 4 is section 4.5, which is inequalities involving quadratic functions. So to solve an inequality, ax squared plus bx plus c is greater than 0, what we can do is graph the quadratic function, and from this graph determine where f of x equals to 0, i.e. where our function is above the x-axis. That would be the area right here and right here. Okay? To solve a less than inequality for ax squared plus bx equals c, what we want to do is we want to determine where our graph is less than 0. So where our function is above the x-axis. Nope, where our function is below the x-axis. That is the typo of the century. So for example, for this function, the blue function, here would be below the x-axis, and for our function in green, here would be below the x-axis. So we're going to learn how to work with inequalities graphically and by doing calculations. So let's use this figure to solve the following. Where does f of x equal 0? So where does y equal 0? Well, that's going to be right on our x-axis. So those are going to be our x-intercepts. So f of x equals 0 at x equals -3 and x equals a positive 4. Now it's going to want these answers sometimes written in set notation, so it's when x is -3 and 4, that's it, those are the only two options. When it comes to greater than or less than or greater than or equal to or less than or equal to, it may want them in an interval, or it may want you to graph them on a number line. So let's go ahead and take a look. So if I have f of x is greater than 0, where does f of x greater than 0 by looking at this graph? We'll switch to green. So that's where my y values are greater than 0. And that's going to be from where x is -infinity all the way to where x is -3, but -3 is not included because it's greater than. So I have from -infinity to -3, union with from 4 all the way up to positive infinity. This is basically asking for what values of x is y positive, or our y values are above the x-axis. Next, if I have f of x is less than or equal to 0, I want to know where is my y values less than or equal to 0. That's going to be along here. This is where my y values are less than or equal to 0. So that's going to be the interval from 3 to 4. So I have that f of x is less than or equal to 0 for x values between -3 and 4. So that's how we can solve these problems graphically. So what if I have 2x is less than x plus 10, and I want to graph the solution set on a number line? How might I go about doing that? So what I want to go ahead and do is I'm going to go ahead and take 2x squared is less than x plus 10, and I want to move this x's over and my 10's. So I have 2x squared minus x minus 10 is less than 0. Now I need to find my vertex, and it's always a good idea to find my x-intercepts. So in order to find my vertex, I know that h equals -b over 2a. So that's -1 divided by 2 times 2, which is 4. So I have a positive 1/4. And then f of h is going to give me my k. So that would be 1/4. Oh gosh, I'm getting really messy, guys. So k is f of h, which is 1/4 times 2 squared minus 1/4 minus, let's go with 40/4. So I have 1/4 squared, that's 1/16 times 2 is 1/8 minus 2/8 minus 80/8. So that'd be a negative 81/8, which is like negative 10-ish. So my vertex is when x is 1/4, k is negative 81/8. So here's my vertex. When x is 1/4, I'm almost down here. So here's my vertex. Next, I want to find my x and y intercepts. This is going to be crucial for knowing when my function is less than 0. So let's go ahead and clear some space and change colors because we love a good color change. So I found my vertex. Go me. You can do it too. So now I want to find my x-intercepts. I can do that by using a quadratic formula, which I don't want to do because I like factoring. So I want to find the factors of a, c that add up to b. So AC in this case is 2 times negative 10, which is negative 20. So some factors of negative 20 that add up to negative 1, that's going to be negative 5 times 4. So I have 2x squared minus 5x plus 4x minus 10 is less than 0, and I can factor. But I want to set these equal to 0 to find my y-intercepts. So I have I just have x times 2x minus 5 plus 2 times 2x minus 5. So I get x plus 2 and 2x minus 5. I set each of these equal to 0. So I get x equals negative 2. So I get x equals 5/2. So those are my y-intercepts, where x is negative 2 and x is 5/2. So here's my beautiful parabola. And what I want to know is where is my values less than 0. Well, that's me right here where I'm going to highlight in red. That's where my graph is below the line. So that's going to be on the interval, but not including the endpoints because it's not less than or equal to 0. It's less than or equal less than 0. The interval from negative 2 and 5/2. This is a 2, I swear. Next, I want to solve where x squared plus x plus 1 is greater than 0, and I want to graph the solution set on a number line. Okay. So I'm going to go ahead and find my vertex. So if I have x, a is 1, b is 1, and c is 1, I've got h equals negative 1 over 2, so it's negative 1/2. That means my k, which is f of h, equals negative 1/2 squared plus 1/2 plus a negative 1/2 plus 1. So f of h equals a positive 1/4 minus 1/2 plus 1. 1/4 minus 1/2 is negative 1/4 plus 1 is a positive 3/4. So my vertex is when x is negative 1/2, y is 3/4. So when x is negative 1/2, y is 3/4 is right around here. And this parabola is going to open up, right? So let's find a couple more points on my graph. What about when x is 0 and when x is negative 1? So if I have negative 1 squared minus 1 plus 1, that's going to equal 1. So when x is negative 1, y is 1. And when x is 0, I'm going to have a positive 1. So my graph looks like this. For what values is my graph greater than 0? Well, it's for all of them, right? For all of negative infinity to positive infinity. And we'd graph it on our number line like this beautiful orange line right here. It just covers everything. So why don't we go ahead and find the following. We're also going to use Desmos to graph this and check our answers. So if I have f of x equals 0, if I have f of x defined as x squared minus 1 and g of x defined as 3x plus 3, let's find the following. The first thing I want to find is f of x equals 0. So I'm going to go ahead and set f of x equal to 0. Well, x squared minus 1, that's going to factor to x plus 1 times x minus 1 equals 0. And I use my zero factor property to determine that x equals 1 or x equals negative 1. We just found our x-intercepts. Let's change colors. Let's go ahead and find for g of x equals 1. So if I have 3x plus 3 equals not 1, 0, I can subtract 3 from both sides. I get 3x equals negative 3. So x equals negative 1. What this is, again, is this is our x-intercept of the graph of this line. So let's go ahead and double check if we were right. So here's a picture. I have f of x equals 0. I can see that it's at 1 and negative 1. G of x equals negative 1 as well. That's what we found. Where are these two functions equal? Well, they're equal here at where x is equal to negative 1, but they're also equal somewhere up here. They intersect twice. So let's go ahead and solve that on the previous page. So I'm going to find c. So I'm going to change colors and set both of these functions equal to each other. So I have x squared minus 1 equals 3x plus 3. So let's subtract 3x from both sides and subtract 3 from both sides. So I have x squared minus 3x minus 4 equals 0. I'm going to factor this. So I say, okay, what are some factors of AC, which is negative 4, that add up to negative 3, and I get 1 and negative 4. So this is going to factor to x plus 1 times x minus 4 equals 0. So my two functions are equal when x equals negative 1, which we already found, and when x equals positive 4. Let's take a look back at our graph. I agree that that is probably right around where x equals 4. So that'd be negative 1 and 4. Where is f of x greater than 0? Well, that's the graph of my parabola, remember, and it's greater than 0 here and here. So as long as x is on the interval negative infinity to negative 1 not included, and 1 all the way to positive infinity. Where does g of x where is g of x less than or equal to 0? Well, that's going to be right here when my graph is below the x-axis. So that's going to be from negative infinity all the way up to negative 1 with negative 1 included. Where is f of x greater than g of x? Well, let's remember that this goes like this. Wait, that's my blue line. And my graph continues to go like this. Okay, so f of x is greater than g of x as long as the f of x value is above my g of x value. So that's going to be here and here. So f of x is greater than g of x from negative infinity to negative 1 and 1 to positive infinity. My next question is, where is f of x greater than 1? We would have to solve that for where our f of x is greater than or equal to 1. So let's go ahead and do that. So I have x squared minus 1 is greater than or equal to 1. I'm going to go ahead and add 1 to both sides. So I have x squared is greater than or equal to 1, but we'll just set this equal to because we're solving. That gives me 2. I take the square root of both sides, so x equals plus or minus the square root of 2. So if we go to our graph and look at it, right, this is why we also need to solve things by calculations, because if we looked at our graph, we couldn't tell that this is the negative square root of 2, and this point right here is the positive square root of 2. All right? So that is the end of chapter 4. If you have any questions, please feel free to reach out.